Today is April 9th, 2026. We have our business intelligence lecture today. The lecture is going to be about deep learning by hand first, and then we will see another topic. The topic that we will see today is called convolution. It's an important technique we use to extract relevant information from data. Okay, so we have here an example. We have an image, okay, as you see. And we perform a convolution to extract the edges of the toy and the different parts of the image in a mathematical manner. So we learn today how to do this in a very structured way. Okay, so for background or introduction, convolution is a technique used in image processing. Is the process of summing each element of the input image multiplied by a so-called filter with its neighbors. This is important, okay? We're talking about neighbors. Intuitively, the pixels that are close to each other. For instance, the orange here is we can see that the toy has an orange in the mouth because all the orange pixels are together. Okay. So this convolution, this is an important remark. This convolution implies that we can measure distances between elements of the domain. In other words, the domain is Euclidean. This is important, okay? Examples of Euclidean domains. Are images, videos, audio files, and so on. Examples of non-Euclidean domains where we cannot implement this technology like we are explaining it today are, for instance, networks. Okay, in a network we cannot measure a distance. Okay. The filters used are called kernels. Okay. Kernel comes from algebra. The German word is Kern. It means center. So in this case, a kernel is a matrix or a tensor that shapes the convolution. We will right away see what that means. All right, so but before we jump into that, let's explain what is a color image. Okay, so what is a color image? Let's try to, just like we have it here. Okay, let's try to understand that. So when we have an image, this color image has, in reality, one dimension here in the horizontal, one dimension here in the horizontal, which is like the x-axis, one dimension in the vertical. So it has like, I don't know, 350 pixels. 350 pixels. And then so, ich lasse niemanden mehr rein, okay? Also ich verstehe nicht, warum es nicht geht, pünktlich zu sein. But in reality, this image is the superposition of 3 channels. One channel that is red, all the pixels in red. That channel is red. Then there's a green channel. Again, same thing, exactly the same number of dimensions, and then there is a blue channel. So that the image in reality is like a cube, like a tensor that has 350 pixels on the x, 350 pixels on the on the epsilon, and then 3 channels. These are these 3 channels, RGB. Okay. The values of each channel are between 0 and 255. So that is 256 positions. The reason for this is that each byte has 8 bits. Each bit can attain 0 or 1. So 2 to the power of 8 equals 256. So each one of the pixels that you see, each pixel is in reality 3 values superposed. One for R, one for green, one for blue. Okay, so each has 3 values superimposed. Okay, for instance, 137, 38, 205. One for R, one for G, or one for B. So are you cool with that? And that gives a color. Okay, whatever. Any questions? Irgendwelche Fragen? Daumen hoch oder passt? Good. Then once we have understood that, and for instance, of course, that we see here the orange, all the pixels are orange are together. If the orange pixels would be like, I don't know, distributed randomly, we would not see a toy with an orange and in a wooden room. We would see something different. Okay, we would just not recognize. That's why here we can apply excuse me, we can apply this method. All right, so now let's see what are input filters or kernels, okay, and differences. Okay, so kernels may have many shapes and sizes. Okay, the kernels make up filters which are a parameter in the convolutional layer. Okay, this the kernels can be used for different purposes, like you can use kernels to perform edge recognition. Just like we have in this example. Okay, so there's a kernel that has been used there to recognize the edges and put the background in blue. Okay, so that's edge recognition. Then we can also go ahead and say we want attention. We want to focus only at the things that we were looking at. We can go ahead and say, okay, we want blurring. Okay, we just want to make one face just not being, or whenever you discover a face, just blur it so that nobody can recognize it. So there are very many types of filters. There are filters to turn the image red or blue or sharp, or there are many ways to filter an image. So let's see some examples. Let's say we want to get some edge recognition. We would go ahead and have a 3x3. This is, the examples are going to be 3x3. And then what we would have would be like this. Okay, just pay attention and try to understand the logic. So say we go ahead and say 1, 0, minus 1, 0, 0, 0, minus 1, 0, 1. Okay. So here we are looking at, here in the middle is 0. So wherever we're looking is going to be cancelled. And we are going to focus on the edges. That's why we have our edge recognition. Only the edges are non-zero. Okay? This makes sense? Yes, no, maybe? Okay. Well, that's an edge recognition filter or kernel. Let's go ahead and get the second. Let's get an attention kernel. Okay, so we get here different kernel that we're going to call attention kernel, and again 3 by 3 just to make things easy. Now our attention kernel is going to be 0, -1, 0, -1, 4, -1, 0, -1, 0. Okay, so here you see the corners are 0. We have in the middle whatever we are looking at, it's very strongly multiplied by 4, and the things around are multiplied by -1, so they are made less relevant. Okay, so here the middle is highlighted. Okay, of course we can make it stronger if we go ahead and say instead of multiplying by 4, we multiply by 8. Okay, this is a stronger attention kernel. You cool? And there are many ways to do this depending on the coefficients you put there. Okay, depending on what you want to get. All right, any questions? Okay, now let's see how do we perform the actual convolution. Okay, so we get an example. Imagine I give you following our channel. Okay, so let's say I have here 1, 1, 0, 2, 1, 1, 2, 1, 1, 0, 0, 1, 2, 1, 1, 1, 2, 2, 1, 1, and 1, 0, 0, 1, 0. Okay. Of course, we could have, we would do the same for each channel. But I'm just going to do it for the red one. Same thing happens if we go ahead and do the same for green and for blue. Okay. Imagine I give you an attention kernel 3x3. So this is an attention kernel. And this is going to be 0, -1, 0, -1, 4, -1, 0, -1, 0. Okay. And we define one parameter. So this is given. We define a convolution parameter called stride s equal 1. Okay, I will explain just what that means. All right, so we go ahead, and what we do is we're going to slide this window like this. First, we're going to multiply this with this window. Then we're going to move it 1 pixel to the right, because s is 1. If s would be 2, we would move it 2 pixels to the right. Okay. And once we have done this, we move it again until we're done, until we hit the end of the image. Once we hit up the end of the image, we move 1 down, multiply again, move it again, move it again, 1 down, move it again, until we're done, and then we are done with our convolutional window. Okay, so let's do the first one here. The first window is going to be this one. Okay, you have the video, so you can pause it anytime you want. So we have a red domain 1, 1, 0, 1, 2, 1, 0, 1, 2. And then we're gonna multiply it by our filter. How do we do it? Is simpler as chewing a gum. We do 1 times 0, 1 times 0, okay, plus 1 time -1, 1 time -1, plus 0 times 0, 0 times 0, plus 1 time -1, plus 2 times 4, plus 1 time -1, plus 0 times 0, plus 1 time -1, plus 2 times 0. Okay? You see the most important one is going to be the center of our window. This yields -1, -2, plus 8, 6, minus 1, minus 1, this is going to be yielding 4. So our convoluted red layer is going to be having here the first number here, 4. Any questions on this? Can you give me a thumbs up or? Okay, so we do the next, thank you. We do the next example. The next example, as I said, we are moving from here to the next window. Okay. Because we have a stride of 1, we move it 1 pixel. 1, 0, 2, 2, 1, 1, 1, 2, 1, and then same filter. This doesn't change. It's the same for the whole thing. We multiply, and then 1 times 0 plus 0 times minus 1 plus 2 times 0 plus 2 times minus 1 plus 1 times 4 plus 1 times minus 1 plus 1 times 0 plus 2 times minus 1 plus 1 times 0. And this is going to be equal to minus 2 plus 4, 2 minus 1 is going to deliver a minus 1. So here we have a minus 1. Okay. We move again. 0 to 1. 1, 1, 0. 2, 1, 1. Times, again, the same filter. 0, minus 1, 0, minus 1, 4, minus 1, 0, minus 1, 0. We perform the calculation again. 0 times 0 plus 2 times minus 1 plus 1 times 0 plus 1 times minus 1 plus 1 times 4 plus 0 times minus 1 plus 2 times 0 plus 1 times minus 1 plus 1 times 0. This yields minus 2. Minus 1 minus 3 plus 4, 1. Minus 1 is going to be yielding 0. Okay? Good. You get the concept. We can do it a little bit faster. Of course, in the exam, you need to do it explaining every step. Don't forget, otherwise you don't get points if you don't explain. So if we do this for the next window, in our minds, 0 times 1, minus 2, minus 2, 0 plus 4 is 2, minus 2 is 0, and then I get to a minus 2 here. So the next one is going to be minus 2. In case I make a mistake, just correct me, please. 0 times 2 minus 1, 0 minus 2, plus 8 is 6, minus 1 is 5, minus 2 is going to be 3. Let me do it again. 0 minus 1, 0, minus 2, plus 8 is 6, minus 1 is 5, 0 minus 2 is 3. So next one is going to be 3. Next one is 0 minus 1 minus 2 is minus 3, plus 4 is 1, minus 1 is 0, and minus 1 is again minus 1. Sorry, something happened there. Okay, weird. So I got here minus 1. What did I get in the other one? Don't remember. Getting old. Minus 2, minus 1, minus, no, sorry. Minus 1, minus 1 is minus 2, plus 8 is 6, minus 5 is 5, minus 2 is 3. So it's going to be a 3. And then the next one here, 0 minus 1. Minus 1 is minus 2, plus 8 is 6. Minus 2 is 4. So I get a 4 here. Let me do it again. 0 minus 1, 0. Minus 1 is minus 2, plus 8 is 6, minus 2 is 4. Good. Next is minus 2, minus 4, plus 8 is 4, minus 1 is then 3 again. And the last one is minus 1, minus 2 is minus 3, plus 4 is 1, minus 1 is 0, minus 1 is minus 1. Okay. Good. So, are we cool? Any questions? Daumen hoch oder Daumen runter. Ist jemand überhaupt da? Ja. Gut. Dann, was wäre wenn, what would be if? So we have converted a 4 by 4, no, 5 by 5, sorry. Red channel into a 3 by 3 convoluted red channel. Okay, with a stride with a 3 by 3 kernel and stride equal 1. What if we keep all parameters equal, but make stride equal to. Okay. So now what we would have is this same problem. The same problem. Let me copy paste it not to avoid writing it again. Okay, so this is our same problem, but now here our stride is 2. Okay, I guess I need to do it again. I don't like it. I need to erase this. Let me do it again. So now our stride is going to be 2. This is cleaner. So we'll copy it again. What would happen there? Okay. So now what we get is this logic. We have a convolutional layer 3 by 3. Okay, same as here. We have the first one is the same, but then we jump not 1 pixel, we jump 2 pixels. 1, 2. Okay. And then we don't jump 1 pixel down, we jump 2 pixels down. 1 and 2. So what we're getting, in fact, is a 4 by 4, it's a 2 by 2 matrix. Okay, so what we're getting is, instead of multiplying 1, 1, 0, 1 to 1, 0, 1, 2, this is the red, this is the kernel, 0, minus 1, 0, minus 1, 4, minus 1, 0, minus 1, 0. Okay, we get here the value 4. And then we jump to 0, 1, 0 to 1, sorry, 1, 1, 0 to 1, 1. So we jump to that, and that is yielding 0. And so on. So at the end of the day, what we're getting is a 4, 0, 4 minus 1. So convoluted red layer. Okay. So if we change the stride, we get a 2 by 2 output. In other words, we get less resolution. If we increase the stride, we get less resolution in our image. The price we pay for being faster, we just have 4 computations here, is that we get less resolution. Okay? Are you cool with that? Please go ahead. No, you're not wrong. This is a very good question. What's your name? Sami. So Sami's question is a very good question. Imagine now, so thank you, Sami, for your question. Let's see what happens if we go ahead and say, hey, I want even faster convolution, I want even faster computation, so I'm going to make stride like 3, okay? Interesting. What would happen there? Well, we would go ahead and we would say, yeah, cool, we want to do it faster, so let's take stride 3. Let's see what happens. Okay, so I would go ahead and say, I would go put it there, okay, and then I would try to jump 3 pixels and I'm out of bounds, okay, so I cannot do it. And then I go 3 down and I'm out of bounds again, and I go 3 again and I'm out of the city, I'm out of town, so no problem. I would only get the simple result of, would be like, we would just get one number. And this is certainly a problem, okay? So what you can do, Sami, and the rest, the solution that has been found to do this is called padding. Sami, are you listening? Good. So padding is the solution for your problem now. Padding means adding zeros all around the image to make sure our convolution does not lose the necessary information. Lose. Oh. All right. No, I'm not done. All right, so what does it mean to do it? What it means is that following strategy. So if we say stride, it's going to be 3, and padding is going to be 1. Okay, Sami, are you with me? We go ahead and add zeros all around the image with one line and column of zeros all around, because padding is 1. If padding would be 2, I would add 2. Okay, it's like adding a thick coat of zeros. We are not adding additional information. This is just zeros, so nothing wrong there. So this is padding 1, P1. Then if we would go ahead and would do the calculation again, okay, let's do it together. Sami, okay? Okay, so now multiply the kernel with the window. What do you get? 4, I'm not so fast. Yeah, you get a 2. Now, where do I put the window? Here? 1, 2, right there. Very good. Yeah, so now multiply again. We get a 6. Where do I put the window now? Here? You cannot go to the right, yeah. So you're here, you cannot go to the right. So 1, 2, 3 down. Very good. So what's the number now? 1, is it correct? 4 minus 2, yeah, 1. And then where do I put it again? 1, 2, 3. Good. What do I get now? Let me do it. Minus 1, minus 3, plus 4, 1, minus 1, 0, minus 1, minus 1. Very good. So the result, the convolute layer, with 3 by 3 kernel, stride 3, and padding 1 is 2 by 2. Okay? So we have a compromise. We have reduced our computation time without losing information. Of course, we cannot continue, right? Because we are out of bounds. All right, is your question answered? Okay, weitere Fragen? More questions? Very good. So in the next hour, we will look at Cummings clustering, which is a methodology to cluster data. Okay, it's a clustering algorithm. Sorry. Clustering. Cluster means make groups. Okay. So we build groups of data. The intuition of it is that imagine you have like a map of customers for your business. You have your map is in 2 coordinates, and you have these customers, okay, and you have 3 delivery cars to deliver your products. Your intuition would say you have 3 groups of customers, okay, so you group them in 3 groups, A, B, and C. And each delivery car will deliver 1 group, okay? So our algorithm that we learn now gives us the groups. The hypothesis, something that we take for granted, is that data are Euclidean. Means we can measure distances. Okay. K is a parameter giving the number of groups. And K needs to be defined by the user. Actually, this is a weakness of the methodology. A strong point is that this algorithm is fast and efficient. Okay. A strength of the algorithm is that is fast and efficient. Okay, I guess here I need a what? Okay, so the algorithm goes like this. This is the k-means clustering algorithm, step by step. After that, we will implement an example, and you will see it's actually quite easy. Step 0, decide the number of clusters given by k. This is something that you do out of business needs or out of intuition. Okay, so it's a disadvantage of the algorithm, but it's not really a big problem, because usually if you run a business, you know how many groups you want to build based on constraints like number of cars you have, or number of warehouses, or number of factories, or whatever. So second step, or step number 1, distribute the data points in k groups. Step number 2, find the centroid. This is like the it's the mathematical terms for the center of gravity, or die Schwerkraft, Mittelpunkt of each group, that different meanings or different concepts to it. Then step number 3, calculate the distance of the points to the centroids. Step number 4, cluster the points by their distances. To the centroids. Okay. And step number 5, sorry, step number 5 is actually optional. Repeat from step 1 until centroids are constant. So let me put it very clearly. In the exam, if I ask this, if you don't do step 5, you get 0 points. Okay? The algorithm is 5 steps. Ich wiederhole es auf Deutsch. Wenn ich das Ganze in der Prüfung abfrage und ihr macht jetzt nicht den letzten Schritt und verifiziert, dass die Zentren konstant geblieben sind, dann kriegt ihr 0 Punkte, weil das Ding ist nicht vollständig umgesetzt. Okay? Ich lasse diesen Satz auf Video, damit es überhaupt kein Missverständnis entsteht. Gut. Okay, das sind die Schritte. These are the steps. Sorry, these are the steps, but this is just not very clear right now for you. I understand it wouldn't be clear for me either. Let's make an example. If we do the example together and you come along in the example, then it will be like easy as chewing gum. Okay, so example. Imagine we have 5 factories with coordinates 0, 3, 6, 1, 1, 2, 7, 0, and 2, 4. We want to place 2 warehouses. To deliver these 3 factories in an optimal manner, okay, with K means clustering. In the exam, I will not tell you you need to use K means clustering. You need to know it. Okay. So let's paint the factories just to get an intuition. First factory is A, is going to be in coordinate 0, 3. So first factory A is going to be here, A. B is going to be 6, 1, 1, 2, 3, 4, 5, 6, and 1. So this is going to be B. C is 1, 2. So C is going to be this fellow here. D is 7, 0. So we'll be around here. And E is going to be 2, 4, 2, 4. That's going to be E. Okay, so intuitively, which is not enough for the exam, but intuitively, you see there are two groups, A, E, C, B, and C, right? This is an intuition that you should start getting. Oh, yeah, sorry. Yeah. Thank you. Thank you. So this was D, right? And this is B. And then we have A around here. Then we have our fellow C here. And B is 2, 4. So B is 2. No, E is here, like that. So thank you. So this is this could be, I mean, in the exam it would be more difficult, but this could be like some sort of so step 0, we have K is 2 because we have two warehouses, right? Step 1, in the exam I would tell you which are the groups to start. So group to start could be A, B, C, which is not right. Okay, it's not correct, but I know that it's not correct, but I at the end of the day I want you to implement the algorithm. So I want to test you. Step 3 is just to calculate the centroids of the groups. So the centroid of group 1 has following coordinates. We take the x coordinate of A, B, and C, so 0 plus 6 plus 1, okay? 0, 6, and 1, the x coordinates and of A, B, and C divided by 3. And then the y coordinates, 0 plus 1 plus 2 divided by 3. So the first centroid of the first group is going to be 233. And again, I know this is not correct, but I want to test your ability to solve the algorithm under unpleasant conditions. So the exam is not going to be a piece of cake. There's always going to be something hidden that is going to make your life a little bit tougher. But that's how we get the best out of us when things are tough. Okay, so those are the two centroids of the system right now. The step number 3 is going to be calculate the distances of all points to the centroids. Okay, so the distance of A to the centroid 1 is going to be the square root of the x coordinates plus the square root of the y coordinates. I guess to calculate the distance, let me put a note here. Note, if you have 2 points in space in a plane, I guess, if you have 2 points in a plane with coordinates x1, y1, and x2, y2, the distance between these 2 points is given by Pythagoras. Okay, this distance d is going to be the square root of this distance, which is x1 minus x2 square, plus this distance, which is going to be y1 minus y2 square. Okay. I don't know if this is known by you or if this is second nature, but you definitely need to internalize. This is Pythagoras. This is learned when you learned this when you were 12, I guess. So this is 2.535. The distance between A and Z2 is square root of 0 minus 4.5 square plus 3 minus 2 square. This equals 461. So A is going to belong to the first group, okay, to Z1 group. We always take the distance, the smallest distance. If we do the same for the rest of the points, we get 3.804, sorry, and then to the other, we get 1.803. So B belongs to the second group. C is going to be 133 to the first centroid. To the second centroid, this is going to be 4.5. So belongs to the first group. D is 508. D to Z2 is 3.201. So belongs to the second group. And E belongs to the first group again. .201, so belongs to the first group. So once we have done this, we go to the step 4. Say new clusters. So the first group has changed. Now we have A, C, and E, because have the smallest differences belong to the first group, and the second group is B and D, which is basically the intuition we had at first. You see here A, C, and D are together, and B, R, D are together, right? So, all right, so if you think you're done, then think again, because this is not the end of the story. Okay, you need to come back, and this is important for you in the exam. Some people just say, okay, these are the clusters, I paint them, this is correct. No, you need to solve this mathematically step by step. Do not jump any step in the exam. If I don't see that you have the calculations done, then you get no points. Z1 star, the new centroids are the x coordinates of A, C, and E, 0 plus 1 plus 2 divided by 3. The y coordinates of A, C, and E is 3 plus 2 plus 4 divided by 3. So this is going to be the point 1,3. If you see the point 1,3, just for your intuition, the point 1,3 is the middle point of the triangle of A, C, and E. Okay, so this is Z1 star, and the middle point of this line between D and D, B and D, is going to be 6.5, 0.5. You will see right now. Our second centroid is going to be 6.5, 0.5, because it's the middle point between the two we're looking for, right? So 6 plus 7 divided by 2 and 1 plus 0 divided by 2. So this is geometrically the middle point of the two in the group, which is logical. We just place the warehouse in the middle of the two factories to deliver them. So we perform again step number 3, distances to the new groups, just to check that we are that the groups remain. Okay, so distance between A and Z1 star is going to be 1. Distance between A and Z2 star is going to be 6.9. You need to do the calculations with the square roots and everything for all the points, okay? In the exam, don't be mistaken. So distance between B and Z1 star is going to be 5.4. Distance between B and Z2 star is going to be 0.7. So belongs to the second group. Distance between Z and Z1 star is going to be 1 again. Between Z and Z2 star is going to be 5.7. So belongs to the first group, and so on. So distance between D and Z1 star is going to be 6.71. Distance between D and Z2 star is going to be 0.7. So belongs to the second group. Everything in green. Right now we are almost done. Distance between E and Z1 star is 0.7. Distance between E and Z2 star is going to be 5.7. So this is going to be it, right? So clusters remain constant. The groups are A, C, E, and groups are B and D on our centroids or our warehouses. Are situated at the coordinates 1, 3 and 6.5, 0.5. Okay. Any questions regarding this. So I'm going to look for a the question that I asked in the last exam. Regarding this. Just 1 second. No, I didn't ask this in the last. Wait. The previous to this. No, I didn't ask it either. I'm looking if I asked this in one exam previously, just for you to. Yeah, here. So let me just make a screenshot. Okay, so this question was asked in the exam in the winter semester 24 to 25, so that you have something that you can plug. So how we would go to it. Okay. So this was an exam question. Right. Exam question. Winter semester 24-25. Calculate the positions of 2 warehouses. This was 20 points in the exam, okay, out of 100. The position of 2 warehouses for the plants with X and Y positions using known clustering algorithms. I don't say it's Cummins clustering, but you need to know, okay? So your plant 1, P1 is 2, 3, P2 is 0, 2, P3 is 6, 2, and P4 is 60, right? So we know that K is 2 because we have 2 warehouses, okay? And then we go ahead and say, okay, our first centroid is telling us to start with plant 1 and 3, so it's 2 plus 6 divided by 2, 3 plus 2 divided by 2. So this is the first cluster is the point 4 and 2.5, and the second centroid is 6 plus 0, so 6 plus 0 divided by 2, and then 2 plus 0 plus 2 divided by 2. So this is the point 3,1. Then we calculate the distances between P1 and Z1, which is going to be 2 minus 4 square plus 3 minus 2.5 square. If we do that real quick with our calculator, we go ahead and get 2 square plus 0.5 square, and then square root of that, that's going to be 2.06. The distance between plant 1 and Z2 is going to be a square root of 2 minus 3 square plus 3 minus 1 square. So this is 1 plus 4 is 5 square root equals 223. So the first point belongs to the group 1. If we do the same for the rest of the points, we get similar results. 0 minus 4 plus 2 minus 2.5 square. This is 16 plus 0.5 square root. That's going to be 403. And then distance between P2 and Z2 equals square root of 0 minus 3 square plus 2 minus 1 square. That's 9. That's square root of 10. That's 3.16. So 0.2 belongs to the second group. Distance between P3 and Z1 equals square root of 6 minus 4 square plus 2 minus 2.5 square. That's 4 plus 0.5 square equal, and then square root 206, and distance between P3 and Z2 equal 6 minus 3 square plus 2 minus 1 square. That's 9 plus 1 equal 10 square root 3.16. So it ain't gonna be group 2, it's gonna be group 1. So P4 to Z1 square root of 6 minus 4 square plus 0 minus 2.5 square. That's 4 plus 2.5 square equal 1025 is 3.2, and then P4 to Z2 is equal 6 minus 3 square plus 0 minus 1 square is going to be 316 again. So equaling going to the second group, right? So our new groups are group 1 star are gonna be P1, P3, and group 2 star are gonna be P2, P4. Okay, so our next centroids are gonna be different. If we take 1 and 3, then we get 2 plus, wait. No, we have confirmed that the groups are the same. No, the groups are the same, so the algorithm is filled, okay? Groups remain constant. Okay. And the centroids remain. So, any questions? Daumen hoch, Daumen runter. Gut. Dann halte ich hier das Video.